try it. There we go. That's pretty good. Welcome back to Arcade. I am Super Tommy, and this is part 5 of creating a side-scrolling platformer, a winter-themed side-scrolling platformer with phaser 3.50. Now, in the last video, we added collectibles, these stars here that you see. Oops. Space. This one is just out of reach. So now in this video, we're going to add some spikes so that we can get hit. And then after that, once we have this base of colliding with enemies or colliding with obstacles or enemies set up, we're going to add a health bar and then a more complicated snowman enemy that'll move around, since our spike is just going to stay where it is and not really move. So it's really an obstacle more than an enemy, but there are similar concepts. Now, if you've been enjoying this series, do hit that like button. Now, let's get started adding spikes. So we're going to add spikes in our tile map. Let's do that first. Let's go to tiled. All right, so here we are in tiled. So now I've got these spikes set up, or selected rather, and they're in here. So you can just pick either one tile, 2 tiles. If you press shift, you can do 2 at a time. You can do 3, whatever you want. So we're just going to use these 3. And we'll show you how to add another tile layer if you want to organize your tiles a little bit better or differently. So in tiled here on the right, you see the layers panel. Just click this new layer button. I'm going to make a tile layer. I'm going to call it, let's call it obstacles. And then now with our stamp tool and our selected tiles here in the tile sets area, we're just going to drop the tiles here, print them right there. So now they're on the floor. Now we start here. That's the penguin spawn. So we start here. Now we have these tile pictures here. Now they're not really going to do anything because they're just pictures. We could use the same system that we used for the floor here, these tile sprites, to detect if we hit it. But you see the spikes are not quite as tall, right? So each one of these, right, the blue is the exact size of the tile. It's bigger than what the hitbox should be. So what we can do instead is go to our objects layer, right? We create these tiles, the display, the sprite, just the visual part as a static image in our tile map. And then to handle the actual hitting, the hitbox, the collision with our player, we can add an object like we've been doing in the objects layer. So let's just select the objects layer, select this rectangle. Now you could, of course, go fancier, but we can use a rectangle here. And then just make a rectangle that's basically correct, like that, right? Now we're going to name the spikes. And like we've done before, so now these are spikes, star, 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 and our spawn points. So now let's save that. Now make sure you go to File, Export. After you save, it's going to export a JSON file. Now let's go back to our code. Okay, so if we come here, let's maybe refresh. Let's see, we did save, right? Save, File, Export. Oh, right. We made a new tile layer. Go to game. And I can be smaller. So we made a new tile layer, right here, obstacle. So in our code, we have to actually create that layer and so that it'll draw. So it's very similar to what we did earlier with ground. So let's go here. So map.createLayer. Now we called it obstacles. We're going to use the same tile set. Now we should see it. And there it is. Ta-da. So there you have the tile set drawing. So now we want to actually be able to interact with it. when the penguin lands on it. So these are our objects in our object layer. Just go here, we're gonna add another case here, and we called it spikes. So we're gonna wanna do, we're gonna add a rectangle, just say simple matter rectangle. So this dot matter dot add dot rectangle. So just make a rectangle. We're going to give it an x and a y, x, y, and a width and a height. Now we do have that information. Right now we're destructuring this object data object into these variables x, y, name, width. So if we go here in phaser.types.tilemaps.tiled.object, and let's see, can I objects? Okay, let's see if I can get the types. There we go. So now you see there's all these properties on the tiled object, and height is one of them, but it is potentially undefined. Now, because we've set it here, right, we've given this a width and height here. Let's select object, this guy. So we have a width and a height. Let's see, where is that data? Oops, not there. I know I've seen it before. Color, well, nonetheless, you see that there is an actual like size here. And that's going to be given to us in this height property, just like the width. We go back here, let's just add a height. We don't ever want it to be undefined. If it doesn't have it, let's just say it's 0, so we don't have like nan errors. If you try to add like 1 to undefined, you may get nan or not a number. Okay. So now we can use height. And then there's some options we're going to give it. Now we're going to make it static since the spikes aren't going to move. So is static true? Now let's just see what we got. So now you see that it did create this blue rectangle based on the size that we defined in x, y with height. Now it's offset because the way we just need to offset the half width, half height like we've done here for the penguin, and we could have done for the stars. So let's do this. Let's just set it. Since you see it's basically doing 0, 0 up here in the middle of our rectangle, but we want it to be over here. So it's just a matter of the x and y coordinates from the tiled map to the rectangle being made here. So we can just adjust for that. So it's going to be half width. Now we know that because you see we want it to move by x, horizontally by half of the width. So we do that. Let's just see. Right, that's better. Now we want the same thing on y. I want to move it down by height half. Height times 0.5. And there it is. Look at that. Now it's not, nothing happens to us when we land on this spike because we haven't added that. So let's go here, let's close this. So now we were adjusting for collisions with the floor in write.setOnCollide. So when Matterjs gives us a collision pair, when two objects collide with each other, we get this information. And we're using this check of the game object to determine what to do, right? Either there's data on the object that we're hitting, that's how we did the stars when we were collecting. And for the floor, we're just checking if it's a tile body, it's a floor. Now we can't really do this here the way we've set it up to use a rectangle because there will be no game object. So let me just console.log the body for you, and we can look at it and see that there will be no game object. So how are we going to know what we hit on? So this is the tile tile body that we hit here. So let's jump over here, hit. All right, so now we landed on this ID6. This is the rectangle body. This is the actual spike thing that we made. And you'll see there is no game object. Let's see. You should say game object. No, right here. So we don't have a game object. So how do we know we've hit a spike? Because it could be any rectangle that we've hit. So now there's a few ways to do this. We're gonna use a separate class and an abstraction to let you be able to use this later for any kind of thing that you can hit on without having to use any game objects. If you're using Matterjs, rectangles, circles, other shapes that it has, star, polygon, that'll all work with this system. So let's come here. In here, in our scenes folder, you can put it somewhere else. I'll just put it here. I'm going to make an obstacles controller. .ts. So what this is going to do is we're going to add every body created to this obstacles controller with a name. Now the name's going to act like a type. So then we can look it up. We're going to look for a type spike given this body. And each body has an ID. So you see ID 6. This is a unique ID for each body. We're going to combine the name with the unique ID. So that's going to be the key. We're going to key each body by this name and unique ID. So now we're looking for a spike, let's say. We're going to do spike plus the ID to see if we have the spike and if it is a spike, and then we can act accordingly. So I'll just show you how to do it. It'll make more sense seeing the code and seeing it in action than me describing it. Okay, so export default class obstacles controller. Now we don't need a constructor. Now we're going to have a map of string key to something. Before we do that, that something could just be the matter body, and that would be fine. Should we do it that way? Let's do it that way. At least let's see. So we're going to call these obstacles. It's going to use a TypeScript map, and it's going to be string by matter. All right, new map string matter. Okay, hang on a second. Let's see if we can get some. There we go. Matterjs dot body type. So that's what we're going to be putting into this map. So let's add an add. Now the name is going to be a string. It's going to be like spikes or spike or whatever you want, lava, any other obstacles you want to add, plus a body, which is a Matterjs body type. Now we want to make a unique key for this. Now because body.id, you can see here, it's a number, it's an integer, and it is a uniquely identifying number generated by Matterjs. So we can trust that this is going to be unique for every single body in our game. So we need a way to generate this key. So let's say our key is going to be the combination, this is a string interpolation, of the name plus, I'll add a dash, dash the Matterjs body ID, right? So now if whatever name you put in, the number is always unique, so you're always going to have a unique key. Then we're going to do this dot obstacles dot set. So we're going to put our body into this map at this key. All right. Now we can also do a little check here first. If this dot obstacles dot has, if this for some reason we've already added a body with this key, and that should never happen. The key should be unique. We can do throw new error. Obstacle already exists at this key, so that we know something is wrong. Now that we add them, so we'll add them to this controller as we create the spikes. So we're going to do that in here, this place. So now let's just save that. Let's come here, collapse that. So let's at the top here in our class fields area, make a obstacles, and it's going to be a type obstacles controller. Now we could do new obstacle controller here, but the way Phaser works with scenes, it does get reused. So this only get called one time, the first time the scene is made, not each time it's run. So we can just do it in init. So this dot obstacles, new obstacles controller, and we can actually, for easier to make things more simpler, later we're going to use this exclamation as the non-null assertion operator in TypeScript. This just is telling TypeScript to trust us. Obstacles is never going to be null or undefined. Now we're just going to trust Phaser that init will always get called when the scene is run, and that should be the case. Okay, now we have this obstacles controller. When we make our spike here, let's put this in a variable, spike. Now we're going to do this dot obstacles dot add. Now we're going to call it spike, or let's call it spikes. And we're going to pass in this spike, right? So this is the body. This is the Matterjs.body type. That's what we're expecting in add here, right? Exactly that. We make a key with the name, which is spikes dash the ID, in this case 6. And every other Matterjs body will have a unique ID. So, it could be spikes 12, or it could be lava 16, but it'll always be unique because the number is going to always be unique. Okay, so good. Let's save that. Okay. So now that we have a map, now we can check that map. So what we're going to do, go back to obstacles controller, and all we want to know is the body we've gotten. So now in this player controller, we're going to get a body, right here. Want to know, is this body a spike, right? And if it's a spike, we're going to handle it a certain way. If it's lava, we're going to handle it a certain way. If it's a spinning chainsaw disc, we're going to handle it a certain way. So let's add a method called is. You can think of another name. So basically, is spike. So is this body a spike, or whatever it is you're trying to check. Now we're going to do that by making the same key. So we could copy this and paste it here, and that would be fine because this is a very small class. But we can also create a function here, a create key function, let's say, so that we can have this key heuristic in one place, string, and then just say ID is number, and we're going to return basically this. So let's copy this, and then just ID, right? So now it's a consistent key creation heuristic in the create key method function. Oops. Now we just do create key, give it a name, and give it the body.id. Now we can do that here, and the logic is abstracted into a function. So if we ever want to change it, we change it in one place only. All right. So now, if we don't have this obstacle in the key in the map here, so has key. So if this key does not exist, that means it is not a spike, or we have never seen this body before. Return no, or return false. Otherwise, we can return true right here. So is it a spike? Yes. If it has that key, then it is a spike. Otherwise, it's not. So if you pass in like chainsaw, and all we have are spikes, it will not be, because this ID, this body ID, is unique. Okay, so now if we come back here to check whether this body is a spike, we would do obstacles.is spikes body. So we need to give our player controller here access to the obstacles controller. So let's pass that in to the constructor and add that in the class fields area, obstacles controller. This dot obstacles. Now let's go back to game. Here, we're going to give it the penguin, the cursors, and obstacles. right? When we create our penguin, when we create the player controller, we're going to give it all the things it needs. Save. That's an obstacles controller. Let's go to player controller. Now we have access to the obstacles controller. So when we come here, we can do this dot obstacles dot is. So is spikes, right? Let me just check. We say spikes. Now we can use an enum here. In other videos on the arcade channel, we've talked about using enums. And in fact, in various blog posts on the blog, we talked about that too, or const strings. We're going to type this because typing could be error prone. You may forget somewhere and use do spike instead of spikes. But anyway, we'll leave it like this for now. So is spikes body. So now we can just do if the body is a spike, we're going to do something different. Right? And so let's just say console.log is spike. Now we'll just test that and see. And go down. And there it is spike. So it is a spike. So now when it is a spike, we're going to want to basically, let's just say, bounce you up and then maybe blink you red a couple of times. So we'll show you how to do that. So we're going to use our state machine now. We talked about that about 2 videos ago, and we created here. This is a great use of the state machine too when you get hit. So let's see, .add state. We're going to call this spike hit because if you got hit by something else, you may want to handle it differently. So on enter, let's say this dot spike hit on enter. Now we got to make that method. And up here, we're going to want to do this dot state machine dot set state spike hit. Okay, now let's make a spike hit on enter. So private spike hit on enter. So what we're going to want to do, we're going to send you up. So very simply, this dot sprite set velocity y, like just say -12, basically the same as the jump. You can adjust that. And then we are going to send you to the idle state. Let's see how this works. Oops. Well, this is not right. Okay. If obstacles that is spikes. Oh, sorry. If not has, one little thing can make all the difference. Okay. Oh yeah, so the test we did earlier was silly because the second it landed, it was the spikes. Nonetheless, so our test was bad. Okay, here it is, and boom. So we're gonna hit the spike and we get vaulted up, like a start. Anywhere you hit the spike, you're gonna get vaulted up, right? So that's pretty good. Different obstacles can do different things, right? That's why we have a different state for you can have different states for each, and we made one called spike hit. Okay, so now let's actually blink our penguin red when we do this. Now we've done this blinking effect in our dungeon crawler series, and we'll do something similar here. We're gonna basically tween the tint, and it's gonna be slightly more complicated than just simply changing the tint from white, which is what it is now, to red and back. Now we did a video on color tweening. You go to youtube.com/arcade, pause that videos. You can find our video on color tweens. Let's see, how to tween colors in phase 3. We'll link to this video in the description box below. And we'll also show you how to do it right here quickly. But if you want more information, do check out that video. So what we're gonna do, we need the scene, right? And we don't have it right now. So let's go out here, or in the constructor rather, we're gonna pass in the scene. It's gonna be a phaser.scene and private scene phaser.scene. Go to game. We're going to pass the scene in here, so which is just this. Since we're in the game scene, the scene is just this. In our player control, we passed in the scene. This, okay, now we're going to do this dot scene gets the passed in scene. Okay, so now you can come down here and do this dot scene dot tweens. Now we're going to do an add counter because we can't just do a normal tween to tween a tint value from one color to another. We're just going to do a slightly more complicated counter. And I'm going to count from 0 to 100. It could be any number of values, but 0 to 100 is just easy to think about. Now let's just say 100 milliseconds for the blink. Now we're going to repeat this, let's say 2 times. It'll do once and then repeat twice, so about 3 times in total. We'll do yo-yo, which just means it's going to go to a color, come back to the original. That's what yo-yo is. Just like any Snapchat filter or Instagram filter. So now on update, we're going to get a tween here. So this is the on update. So every frame, we're going to, that this tween manager tweens the counter, the number from 0 to 100, we're going to get a callback here, and we're going to do tween.getValue. So this gets us the number between 0 and 100. And let's see, so I've got an example here on the side. This is, I don't remember, there's no need to memorize this. So we're going to do, once we have this value from 0 to 100, we're going to use phasors color interpolate. Color.interpolate. We're going to basically interpolate a color to another color. Now, so that's color 1, color 2, and the length of time in total. And then the current index, so the current time. So which basically is going to be 100, that's our total time, and then the current time is the value. Now we need a start color and an end color. So let's make that up here. Let's call this start color. Now our start color needs to be in the type phasor.display.color. Now we just make that with phasor.display.color.value to color. So this is like any value. It can be a string, a number, or a color-like object. I think that's what input color object is. So we're going to use just a hex number here. Now we know that white is just that. And then we're going to say end color is a red. .display.color, value to color. And red is just the first two. That's R in RGB. And then nothing for the other two. So that's going to be pure red. So we're going to go from start color, just white, to end color, which is red. The length is 100 and index is value. Hear my dog there. They're fighting over beds. Color to object. Now we have that. Okay, so now we're going to get a color out of our color object. So this is going to have R, B, and G for red, green, and blue. Phasor.display.color.getColor. We're going to pass in red, green, blue, like I was saying here. And so color object dot R, color object dot G, RGB, color object dot B. Let's double check here. Red, green, blue. Okay. So now we have the color. We can do this dot sprite dot sprite. Okay. Dot set tint. Dot set tint color. Okay. So this is going to blink us from white to red to white to red to white to red. Let's try it. Ta-da. There we go. That's pretty good. You can adjust the timing. You can give it an ease. Like we can do ease. Let's say phasor.math.easing.sign. Let's just say in out. To give it like different effects or it'll look slightly different, right? That's a little bit faster, looks nicer. you kind of get a little bit more red for a little longer, you can just play with different ease values here. So that is hitting spikes or adding spikes, getting hit by them, and then blinking to note that you've been hurt. Now, there's no actual health here. We are going to add that in the next video. So if you enjoyed this video, do hit like and hit subscribe for more videos on making games for the web with Phaser 3.50.